Hello guys, so today we are here to solve our daily lead code challenge for the day, and this problem is asking minimum number of operations to make the array XOR equal to k. So we are given an integer array nums, okay, and we are also given an integer value k. So integer array nums is there, and then an integer array k is integer value k is there. So the integer array nums, we have to apply, you know, so we have to, uh, do a XOR on all the elements of the nums array, and we have to find out what is the minimum number of flips that we need to do so that the result is equal to k. Okay, so this is the question. So let me, go through the question and then we'll, discuss about how to solve this problem. So we are given a zero indexed integer array nums and a positive integer k. So the input is integer array nums and a positive integer k is there. Okay. So we can apply the following operation on the array any number of times. So what is the operation? Choose any element of the array and flip a bit in its binary representation. So flipping a bit means changing a 0 to 1 or 1 to 0, changing a 0 to 1 or vice versa. So the problem is asking return the minimum number of operations required to make the bitwise XOR of all elements of the final array equal to k. Okay. Return the minimum number of operations required to make the bitwise XOR of all the elements of the final array equal to k. So first of all, we need to find out what is the current XOR. So let's say current XOR value. What is the current XOR value? So let's initialize this to nums of 0, and then we just go through int I is equal to 1, and then I is less than nums dot length, okay, and then plus I. Okay, in this what it will do, current XOR nums of I. Okay, okay, like this, and then so this will be giving us the result that what is the current XOR. Now we need to find out what is the difference of the current XOR value and the intended k. Okay, so to get the difference, we don't need to do anything else. We need to do XOR operation only. So diff is equal to current XOR of k. And now what is the count in this? What is the count of difference in this? So how many bits are set in this diff? So to count that, we will do this int count is equal to 0. And then while diff is not equal to 0, what we will do that we will do diff and diff and diff minus 1. So what is this diff and diff minus 1 will do? This will so what is this whole thing is going to do? This will, this diff and diff minus 1 is going to set the rightmost, you know, uh, set bit to 0. And the number of times we are going to do, so whatever is the value, we are going to set it to the diff, and we will be incrementing our count. Okay. And then just we'll be returning this count. That's it. So let me run this solution. Okay, so let me just run this. Okay. Okay. And then, so it's accepting the, sample test cases. Now we'll submit it. Perfect. So it's getting all of the solutions. So it is a very efficient solution. So let me just, comment what we are trying to do. What is the, you know, current value of the jar operation on each element of the array? What is the current value of doing or performing of, yeah, doing is fine, of doing XOR operation on each element of the array? The difference in the current value of XOR and the intended value. Okay, so as we all know, jar of a bit in the result is set when either that bit is set in either of the operands. Okay, and it is unset in any other case. And here, this is one trick. This is one way to find out how many bits are set in a diff. If diff is any integral value, and we want to find out how many bits of the diff is equal to 1, then we do diff and diff minus 1, and we store that value again to the diff, and we do it, till the time diff is equal to 0, and we count that, how many times it is required to, till the time diff becomes equal to 0. And that is the, actual value, actual, set bit count of that diff. Okay. So this is the, my approach to solve this problem. I'll write one comment here. Count of how many bits in the diff are set. That's it. Okay. So I hope this solution is very clear. I'll just run this and I'll submit it. Perfect.